thousands of times. But if you look at YouTube, knowingly or unknowingly, you guys might be using the YouTube's recommendations. So once immediately you actually go through a specific video, immediately after that, YouTube does recommend you with a lot of other similar videos. The way it actually tries to identify is basically internally YouTube uses item to item recommendations framework internally to build the recommendations platform. The way YouTube does the recommendation is basically YouTube would have analyzed the similar items. It would have mined the similar items within the available corpus, or also it can either look at the similar users like you, or it might have analyzed the patterns. I mean, it might have analyzed the patterns of videos being watched by the similar users, or the patterns of the items, I mean patterns of the videos based upon the items itself, I mean the similar items itself. So through which it actually does the recommendations, guys. So however, to my knowledge, YouTube does item to item recommendations. So we'll deep dive into recommendations later, but just here is just my effort to actually bring up certain use cases over here, like YouTube. So user activity, in order to obtain personalized recommendations, YouTube recommendations combines the related videos association rules, so video association rules, with the user's personal activity over the site. By monitoring the activity, user activity over the site, it actually does the recommendations of the videos based upon the association rules it has built for the videos itself. And this includes several factors. So the activities could include several factors. There are videos that were watched along with a certain threshold, say by a certain date after all, and you don't want to count videos watched by 2 years ago or whatever, some stuff. And also YouTube factors in emphasis any videos that were explicitly liked. I mean, YouTube also consider the likes for the videos, add to favorites. I mean, whenever you add videos to favorites, and given the rating added to the playlist, so whenever you submit the rating for the video and added it to the playlists, so the union of these videos is known as the seed set. So it uses the seed set to actually come up with the recommendations, guys, and then to compute the candidate recommendations based upon the seed set, and YouTube expands it along the related videos as well. So it will try to identify the similar related videos and try to expand the same using this infrastructure. Okay, so another classic example for recommendations is, there is a third-party company called as the NextGlass. So basically, this NextGlass company does wine recommendations. Why is it so important, specific to wine recommendations? Because there are countries, where wine is most frequently consumed, and people actually turn out to the website saying that what's the wine, I should enjoy or whatever. So based upon the user's preferences towards the different wine flavors, what the NextGlass has done was basically it has created entirely a new way of building the recommendation system. They actually captured the DNA samples for most of the wine flavors, wine types, and based upon the preferences you have given previously for different wine types, and based upon the DNA samples of those wine types, this NextGlass has built the recommendations framework, guys. So that's a very advanced way of doing the recommendations, I would say, compared to that of just looking at the user's preferences previously and other similar users. So these guys have built a recommendations framework entirely differently. So the problem statement here is a mysterious rating. So people give at times people give mysterious ratings and adjective based on reviews do little to help consumers decide which wine to buy. So even though you might have lots of data sets, but most of the time, since users' tastes actually vary type person to person, and they change actually mysteriously. So even building recommendations over the user's interests may not be a very efficient way specific to this kind of problem statements like using wines, so they can't even agree amongst themselves. So solution is next class solves this problem by removing the subjectivity and applying science to deliver the recommendations. So it basically, as I mentioned, it actually extracted the DNA samples of most of the wine flavors and through which it actually does the recommendation based upon your previous preferences or ratings, based upon your previous ratings. Okay, and so there are certain other companies as well, not only Next Class, so who does wine recommendations. One is Wine Enthusiast, Robert Pocket, and Wine Spectator. So these are different companies which does extensive wine recommendations as well, guys. So another popular example, which is fraud detection. This is basically a classification system. I'm sure that everyone would have heard about, everyone would have known about fraud detection. So since it's very hard to find out the fraudulent credit card transactions. So again, that's where machine learning comes into picture. So using machine learning, you guys can be able to, by applying the learning techniques like classification techniques, you guys can be able to actually detect or classify the fraudulent transactions from the benign transactions, the good transactions. So a classifier can be useful in predicting which transactions will later be determined to be fraudulent based on known examples of behavior for purchases and other credit card transactions. So we actually, however, building a classification system to identify the fraudulent transactions has to have very good domain understanding, and there are various factors these engines have built on top of the various factors to actually identify the fraudulent transactions. So however, we will learn various interesting classification techniques, especially we actually look into the logistic regression using SGD, stochastic gradient descent, and we'll be looking at the most advanced ones also, like random forests. We'll actually implement random forests on one of the data sets. We also use Navy-based algorithm throughout our session, folks. And as well as previously for recommendations also, we'll apply a lot many algorithms in recommendations as well. Okay, so clustering is one of the most popular techniques which are actually available in Mahout. So I would say clustering is the base for Mahout framework, since Mahout has a capability to process large text data sets. So if you look at this example over here, so I have listed Google News as one of it. Basically, Google News does a clustering of the news articles into different categories, so that based on the categories also, based on this clustering also, they can actually do the recommendations to the end user based upon the end user's interest towards a specific category or towards the cluster of news articles. So for doing this clustering of news articles, clustering techniques can be used from Mahout. Again, ClickStream Analytics is one of the interesting use case specific to e-commerce companies, guys. So ClickStream data is one of the major sources of data to understand the user behavior towards the application. Not necessary that it should always be e-commerce applications. ClickStream data can be mostly, it's like one of the key sources for different domains also, for any domain for that matter, to understand the user behavior. So basically, ClickStream data contains, whenever you log into the application, whatever the activity you perform over the web application, say you visit certain pages, you click on certain things, you spend some time over certain pages, and you scroll through certain page sections. Okay, so all this data will be part of the ClickStream data. This data is it's a key source since we actually withdraw the patterns within the uses of the application by different users. So this can be used to build very good user interface to the users. If you consider e-commerce, they use this data to understand how people are actually taking the how people are navigating through the application and what products they are interested in, which products they bought and which they didn't. So all this information they can mine and they can keep it for either enhancing the user interface or for identifying the problems or for bringing up more revenue specific to e-commerce. So here it says that it can be defined as data about which links a user clicked and at which point of time, and e-commerce business mine and analyze ClickStream data on their own websites. Okay, so let's see what all things can be part of, what all activities can be part of the ClickStream data. So some of the information the ClickStream data seeks to capture is where was the visitor before, where was the visitor before she reached my website, he or she reached my website. So from where the visitors are coming to your website. So that also is possible. And if a visitor came in from a search engine, which search term did she use? So the search terms did they what are the search terms they have used, and what web page did the visitor first access on my website? So what is the page he has visited, and what pages did the visitor access over my website? I mean, in what sequence? So you will identify the pattern within the navigation of the pages within your application, and how much time did the user spend on each page, when and where did the user click the back button on the web browser, and what items did the visitor add or remove from shopping cart. So what are the items he is adding and he is removing from the shopping cart, and what was the page at which the visitor exited from the website. So these are all different activities, not limited. There could be certain other activities also which could give more meaningful insights upon the user behavior itself, guys. So through which there could be so many analytics and so many advantages towards the e-commerce or any other company for that matter, any other domain for that matter. So learning techniques. So guys, at a high level, learning techniques can be classified into two categories. One is the supervised learning and the other one is the unsupervised learning. So let's start with supervised learning first and then come back. So before going to theory here, let me just take an example over here. So guys, given a situation where you have certain data sets along with the labels also, so such type of learning is called as supervised learning, where you train the system with a teacher. When I say with a teacher, with some known data set, and create the model in such a way that the model will actually come up with a further classification. So such thing is called as supervised learning. So let me take a small example here to explain you what is a supervised learning course, and let's try to compare it with the unsupervised learning. So guys, in supervised learning, so if you consider this slide over here, I have taken a couple of data sets. One is the elephant images and the other one is the lion images. So guys, can you please tell me what are the input data sets, input features which actually help us to classify or identify a specific image to be a lion or say elephant? For example, okay, so say weight and say tusk. Okay, then say color, then say what? Say trunk, size. Size could be one thing. So trunk, tusks, and say beard. Okay, so I can take certain features like this. Then let's try to have some input observations with all this data set, guys, with all these features. Say weight could be somewhere around so 90. Tusks are say no. Color as say brown, and then trunk as no. Size as say some 80, and then beard as some yes here. Okay, so if we consider this as one observation along with some label associated with observation, what is the possible label for this, guys? So possible label for this is say lion. Okay, like that we can actually have the input data sets with along with the labels. For instance, let me take another example here. Weight could be somewhere around 1000. Yes, and say black, and say yes, and then say size as some 2000, and then say beard as say no. Okay, and I would call it as say elephant. So like that I can take a number of observations. So here in supervised learning, the idea is you prepare the input data sets along with known sample, along with known labels to each observation, and you use that known data sets in the training phase and create the model in such a way that the model will be capable of learning the associated labels based upon the input observations, and for unseen data sets also the system can be able to do the classification, guys. So such type of learning where you train the system with the known labeled data is called as supervised learning. So let me just go back here. So here you guys can see each of these images has labels along with it, and you are training the learning algorithm, and from there onwards you are using the learning algorithm in the for further classification. So if I represent it over this slide, so this will give us more meaningful information. So guys, you have the training data sets. It could be text, documents, images, anything for that matter, and along with the, so what you do is as a first step, so this is a raw data set, by the way. Since we cannot directly use the raw data set to be trained with using the learning algorithms, the first step you have to do is you have to extract the feature vectors. I mean, you have to extract the features which are needed for doing the classification over here. So once you extract the features in the form of a vector, that's called as the feature vectors. We'll discuss about vectors in detail now. So you use that featured vectors along with the labeled, along with the labels here. So you have the training data set along with the labels as well. So you associate each label for the feature vector and train it using some machine learning algorithm and create some model. Okay, so once the model is ready, once the model is prepared, model is nothing but a computer program, guys. It's nothing but a simple function which is capable of doing the further classification. And now you actually pass the unseen data sets like this without the label. Now you extract the feature vector similar to that of the previous step. In the training phase, we extracted the feature vectors, right? Exactly in the same way you actually extract the feature vector. After that, you pass that feature vector to the model, and the model will start predicting the associated label based upon the feature vectors, guys. So this is a kind of workflow associated with the supervised learning techniques. So let's try to understand some content about it. Okay, supervised learning training data includes both the input and the desired results. For some examples, the correct results targets are known and are given in the input to the model during the learning process. So the construction of a proper training, validation, and test set is crucial, and these methods are usually fast and accurate. So supervised learning methods are usually very fast compared to the unsupervised learning techniques, and accurate as well, since we are training with known data sets, and how to be able to generalize. So give the correct results when new data are given in input without the priority on the target. So let's try to compare it with the unsupervised learning over here. Guys, let me give you an example for unsupervised learning. Unsupervised learning, okay, is a way you actually train the system with without the labels. So let the algorithm actually look at the similarities between the items and try to come up with some grouping within the item sets, guys. So let me take a right example for this to explain in detail. So guys, if you take a small baby into some fruit stall, if the baby doesn't know about actually what is a fruit means, for example, if the baby doesn't have any information about a fruit, say apple, so if the baby doesn't know about the apple name as the apple or mango or any other fruit name, if you take the baby to the to the fruit stall, then still the baby will be able to actually group the available fruits into different categories, even though the baby doesn't really know the labels. Say this is apple, this is mango, or this is something else, but still the baby is capable of grouping different fruits into different categories. For example, by looking at apples, the color, size, and different other metrics, different other features, so it can group, the baby can group it into one category and another category as mango, even though the baby doesn't know about the labels, whether it's an apple, whether it's called as apple, or whether it's called as mango. So such a scenario can be considered as unsupervised learning, where you do not have any labels associated with the data sets, but still by looking at the similarities, by looking at the patterns within the input data sets, we are able to group the data sets into different groups, different categories. So such a learning is called as unsupervised learning techniques. And unsupervised learning techniques are like the most popular learning techniques are like clustering algorithms or unsupervised learning techniques mostly. We'll look at those clustering techniques later in detail. So also one more thing one more thing I wanted to highlight here is, see, humans, we being humans, we are actually pattern-seeking beasts. So when I say we are pattern-seeking beasts, we actually try to look at the patterns at mostly whatever we see and we try to understand. So the initial thing humans usually will do is they actually try to identify the patterns within the input data sets, guys. And yeah, the model is not provided with the correct results. The model will not have the actual labels during the training, and can be used to cluster the input data set into classes. So this can be used to cluster, group, cluster or group, probably one and the same, and the input data set into different classes, different categories on the basis of their statistical properties. On the basis of such features, we can be able to group the input data sets, only cluster significance and labeling. And the labeling can be carried out even if the labels are only available for small number of objects representative of the desired classes. So in the unsupervised learning model, the only difference with that of the supervised learning model is there you are actually having labels associated with each input data set or each observation. Here you are not having any labels associated with it. So you actually extract the feature vectors out of the input data set and pass that to your learning algorithm, and let the learning algorithm to come up with the groups. And you can actually use you can use the groups for further classification as well. So one of the examples is if you have a bowl of fruits over here, so that by looking at the similarities between all these different fruits, you can still be able to categorize into different groups, even though you does not know about the labels of this fruits.